In this lesson, we'll be using the definitions of the trig functions in order to find some unknowns. The first list of identities I want to give you are the reciprocal identities. We mentioned them a little bit in an earlier lesson. Here's a formal list of our reciprocal identities. Sine of theta is really equal to 1 over cosecant theta. Now, let me remind you that sine of theta is defined to be y over r. Cosecant of theta is defined to be r over y. So that's why sine of theta is just equal to 1 over cosecant of theta. Similarly, look up the definition from an earlier lesson for cosine of theta. You would find that cosine of theta is defined to be x over r, while secant of theta is defined to be r over x. And so that justifies this statement. Tangent of theta is just 1 over cotan theta. Cosecant of theta is 1 over sine theta. Secant theta is 1 over cosine theta. And then cotangent of theta is equal to 1 over tan theta. These are your reciprocal identities. Here's our first example. Find each function value. They want you to find tangent of theta given that cotangent of theta is 4. Find tangent of theta given that cotangent of theta is 4. Now, I am thinking about using this identity. The tangent of theta is what they're asking me for, and we know that tangent of theta is equal to 1 over cotangent of theta. Let me move the screen up a little bit for us. And so that would imply that this is 1 over, and then cotangent of theta is given, it is 4. So then tangent of theta is simply just 1/4. Not too bad. Let's try another. Now find secant of theta given that cosine of theta is negative 2 over root 20. Find secant of theta. Now, you can look at your list for your reciprocal identities, and you can find that secant of theta is equal to 1 over cosine of theta. Now, the good news is that cosine of theta is given. It is negative 2 over root 20. You can see we have some simplifying to do in this expression, okay, or for this expression. So then this is equal to negative, and this just turns out to be root 20 over 2. Now let's continue simplifying. Root 20 is 2 root 5. Don't forget over 2. And then we know that these 2's divide out, leaving you with a final answer of negative root 5. Good job. Now I want to talk to you about the signs of function values. Signs of function values. Functions should not be plural there. Signs of function values. So we have quadrant 1, quadrant 2, 3, and 4. Let's talk about quadrant 1. In quadrant 1, all of your x values are positive, all your y values are positive, and r, remember r is defined to be the distance from the origin to the point on the terminal side of your angle in standard position. So r, by default, is, or by definition, is always positive. So in quadrant 1, x values are positive, y values are positive, r values are positive. Now, in quadrant 2, your x values are negative, your y values are positive. Negative x values, positive y values, and of course r is positive. In quadrant 3, x values are negative, y values are negative, r is still positive. R is always positive. Finally, in quadrant 4, x values are positive, y values are negative. Now this helps us tremendously. Let's look at quadrant number 1. Remember that all of your 6 trig functions, all of them, are defined to be ratios of these distances. So sine of theta, for example, is defined to be y over r. Cosine of theta is defined to be x over r. Tangent of theta is defined to be y over x. Remember that definition? So if x, y, and r are all positive, that means all 6 trig function values are positive for any angle whose terminal side lies in quadrant 1. I'll say that again. All 6 trig function values are positive for any angle whose terminal side lies in quadrant 1. Now in quadrant 2, that's not the case. Although r and y are positive, x is negative. So the functions that are defined with x will be negative. So let's see, what would that be? That would be cosine. Cosine is defined to be x over r, so something negative over something positive. So cosine will be a negative value. We'll have negative values here. And then secant will also be negative. Remember, secant is just a reciprocal of cosine. So if cosine is negative, secant's also negative, because reciprocals have the same sign. So in this quadrant, so far we have cosine and secant are negative. Now, that's not it. Tangent and cotangent are defined with x. For example, tangent of theta is defined to be y over x. Cotangent of theta is defined to be x over y. One of these values is positive and the other one's negative, so both tangent and cotangent of theta will also be negative here. So cosine is negative in this quadrant, secant is negative, tangent and cotangent. So what does that leave us with? Sine and cosecant are the only positive functions, are the only two functions that have positive function values in quadrant 2. Remember, sine is defined to be y over r, positive over positive. So in this quadrant, quadrant number 2, sine and cosecant are the only functions whose values are positive in quadrant 2. Now in quadrant 3, let's see, cosine is going to be x over r. Cosine is going to be negative over a positive. So cosine's negative. That means secant's also negative. Sine will be y over r. Something negative over something positive. So sine is negative. That means cosecant, its reciprocal, will also be negative. Tangent is y over x. A negative over another negative. That's positive. If tangent's positive here, then so is cotangent. So tangent and cotangent are the only functions whose values are positive in quadrant 3. Now finally, quadrant 4. Okay. Now notice that cosine will be positive. Cosine is x over r, positive over positive. If cosine's positive, its reciprocal is also positive. Secant is also positive. All the other 4 will be negative. So it's very important that you understand and remember this information, okay? Now, some people use a very popular phrase to help them remember all of this, and I don't mind sharing it with you. All students take calculus. All students take calculus. This phrase might help you remember which functions have positive function values, okay? All functions are positive here. Students, that means sine is positive here. And if sine is positive, cosecant's also positive by default. All students take, okay, tangent's positive here, which means cotangent's also positive. Calculus, so cosine is positive here, which means secant is also positive. Now, we know that's not true. All students take calculus, but that would be nice. So anyway, this information at the end of the day is really, really, really important. Remember the signs of your function values. All right, check out this next example. Determine the signs of the trigonometric functions of an angle in standard position with a given measure. Now, the first one is 54 degrees. Now, let's all just be really clear about 54 degrees being in quadrant number 1. Now, you can refer to the information that we just derived. In quadrant 1, all functions are positive. Now, the next one is 260 degrees. Now, 260 degrees is in quadrant number 3. And in quadrant 3, remember, all students take calculus, right? So T is for tangent and cotangent. So for this answer, tangent and cotangent are positive, all the rest are negative. The last one is negative 60 degrees. Now be careful here. Remember that angles that open clockwise have negative measure. Here, let me draw you a picture for this one. I just feel compelled to do it. When we're talking negative 60 degrees, you want to open clockwise. So we're talking standard position. So vertex at the origin, initial side on the positive x-axis. And we want to open clockwise 60 degrees. So this would be negative 60 degrees. So I hope you can see that it is quadrant 4 we're talking about. Now, all students take calculus. So in quadrant 4, cosine and secant are positive, all others are negative. All right, very good. Let's keep on going. Let's look at another example. All right, check this out. Identify the quadrant of an angle that satisfies the given conditions. Tangent of theta is positive and cosecant of theta is negative. So you have to find an angle theta, or excuse me, you have to find the quadrant that meets both of these conditions. Now, I like to do this problem the following way. I know tangent is positive in quadrants 1 and in quadrant 3. Those are your options for tangent being positive. Now, cosecant is negative. Now, remember, if cosecant is negative, that means sine, its reciprocal, is also negative. So I'm going to think about sine. Now, sine is negative in quadrants 3 and 4. So those are your options for that condition. So then what I do at this point is just figure out what they have in common. Oh, this angle must, or the quadrant must be quadrant 3. Quadrant 3 must be the quadrant of this angle, theta, in order for tangent to be positive and cosecant to be negative. So quadrant 3 is the answer. The next one, sine of theta is positive, cosecant of theta is positive. Wait a minute, sine and cosecant are reciprocal functions. So they're going to have the same signs in these quadrants. So it's kind of silly to be considering both of these, right? If sine's positive, cosecant will also be positive. If sine's negative, then cosecant will also be negative because they're reciprocals, and reciprocals have the same sign. Now, so all I really have to think about is one of these. When is sine positive? So sine will be positive in quadrant 1 or quadrant 2. Same is true for cosecant. Now, everybody, this question has two answers, quadrant 1 or quadrant 2, okay? 1 or 2. All right, what I want to discuss next is the ranges, or are the ranges of the trig functions. Now, what I have for you here is an angle, and I am going to allow this angle theta, notice it's in standard position, I'm going to allow this angle theta to increase. I'm going to allow it to go from 0 degrees all the way up to 90 degrees, or allow it to increase at least from close to 0 degrees toward 90 degrees. So here's my first angle, theta. Now, if this is my first angle here that I draw you, this distance here is x, this distance here is y, and this distance here is r. Okay. Now, what I want to show you is a different angle now, theta, in standard position, and notice how these distances change. Y changes, x changes, but notice that r never changes. Here we go. How about a smaller angle? A smaller angle like that. All right, so then this would be theta in there. Okay, this is going to be a little bit messy. But then this, now bear with me, okay, it's going to get a little messy. This distance here would be x. Notice x is larger now, but y is smaller. And r doesn't change. R is the same. Okay? Now, let me draw you another angle. Let's draw a larger angle here, so it's really close to 90 degrees. Okay? Notice that y gets really large, x gets really small, and r is the same. So as an angle theta in standard position increases in value from near 0 degrees towards 90 degrees, the value of r is the same, but as the angle increases, notice that y also increases. Look at the small angle in yellow. The angle is relatively small, y is relatively small. As theta increases, notice y gets bigger and bigger, but it never exceeds r, right? This distance here will never get bigger than r, right? It can never get bigger than r. So then we have this relationship here that y is less than or equal to r. Now I want you to divide both sides by r, would you? Divide both sides by r, and notice what you get, that y over r is less than or equal to 1. I need you to hold on to this, okay? I'm going to ask you to recall it in just a minute. Y over r is less than or equal to 1. All right, now let's consider the same argument, but in quadrant 4. All right, we have our angle here, theta. Let me draw it really quickly for us. There, counterclockwise, right? Theta. Now notice that this is your distance x here, this is the distance y, and the distance r here, okay? Now what I want to do is I want to show you some different angles in quadrant 4. So notice how the y value is changing. Now remember, in quadrant 4, your y values are negative, everybody. So your y value is here, it's negative, and then it's really negative and really negative, right? Approaching negative r, negative r. So then we have the following relationship. Y is always greater than or equal to negative r. Now remember, let's divide this time, let's divide both sides of this inequality by r, like we did last time. That would be y over r is greater than or equal to negative 1. All right, now I want you to take this statement here and the previous statement that I asked you to recall and put them together. So in the a minute ago, we had that y over r is less than or equal to 1, less than or equal to 1, and now we have y over r is greater than or equal to negative 1. So if I combine those two statements, I have the following. Y over r is less than or equal to 1, but it's greater than or equal to negative 1. And y over r is exactly how sine of theta is defined. So we just figured out that sine of theta, all of these function values, that means range, the range for sine of theta will always be between negative 1 and 1. Now, we can build the same argument for cosine. We can draw the same diagram for cosine. Both sine and cosine will have range between negative 1 and 1. Now, as far as tangent is concerned, now it's possible for, here, let me write this down for you. It's possible that x is less than y, x is exactly equal to y, or x is greater than y. So because all of these are possible, and because tangent of theta is defined to be y over x, we will say that tangent of theta can be any real number, as can cotangent of theta. So tangent and cotangent of theta will have range any real number. All right, very good. Now, remember, let me move this up a little bit here. Now remember that secant and cosecant are just reciprocals of the function of cosine and sine, right? And so if, let me pick on sine really quickly, if sine of theta is less than or equal to 1, that means cosecant of theta will be greater than or equal to 1, or if sine of theta is greater than or equal to negative 1, that means cosecant of theta will be less than or equal to negative 1. okay, because they're reciprocals. Now, same thing is the case for cosine. If cosine of theta is less than or equal to 1, that means secant of theta will be greater than or equal to 1 because they're reciprocals. Now over here, if cosine of theta is greater than or equal to -1, I have to read this right to left here. It's kind of awkward. But if cosine of theta is greater than or equal to -1, that means secant of theta will be less than or equal to -1. I'd like to summarize the ranges of all of our trig functions in this table here, and we're going to write the range in two different formats. One will be set builder notation, and the next one will be interval notation. Here it is. Earlier we said that the sine and cosine functions have a range that says greater than or equal to -1, but less than or equal to +1. That's the same thing as saying the absolute value of y is less than or equal to 1. Now we're using y here because we're talking about the range, right? And range are y values or function values. So the absolute value of y is less than or equal to 1 is the same thing as saying y is less than or equal to 1, but greater than or equal to -1. And this is interval notation for saying the same thing. Tangent and cotangent, we said y is any real number. So this is set builder notation. The set, let me show you how to read this, the set of all y such that y is a real number. In interval notation, all real numbers, okay? Let me go back here. I forgot to read this for you. The set of all y such that the absolute value of y is less than or equal to 1. For secant and cosecant, it's the set of all y such that the absolute value of y is greater than or equal to 1. That's the same thing as saying all of your y values must be less than or equal to -1, union greater than or equal to 1. It'll be very important that you keep this table and this information really handy for you, and try to remember it as best you can. Okay, example 4. Determine whether each statement is possible or impossible, and it has everything to do with the range. First one, cotangent of theta is -0.999. Remember that the range for cotangent is all real numbers. This is a real number, so it's valid. So this is definitely possible. I'm just going to put P for possible. Cosine of theta is equal to -1.7. Remember that the range for cosine is between -1 and +1. This number is not inside of that range. This number is less than -1, so therefore this is impossible. The next one, cosecant of theta is equal to 0. Remember that the range for cosecant is less than or equal to -1 or greater than or equal to 1. 0 does not fit inside of that description, so this is impossible. Okay, all because of the ranges of these functions. All right, a brand new example. Suppose that an angle is in quadrant 3 and tangent of theta is equal to 8/5. Find the values of the 5 remaining trigonometric functions. All right. Now, please remember that we already proved that you can choose any point you want on the terminal side of angle theta. So let's choose the point on the terminal side where y is -8 and x is -5. Remember, tangent of theta is defined to be y over x. So watch this, everybody. Okay. So tangent of theta is y over x, right? Like that. I replaced tangent of theta with what it's equal to, how it's defined. Now this implies that y is -8 and x is -5. Why negative? Well, because they told us in the beginning that we're in quadrant 3. And in quadrant 3, both x values and y values are negative. And after all, if you divide a negative by another negative, you get something positive, and our function value for tangent is positive. Okay? Now, we're going to need to figure out what r is. Now, r is, do you remember that it's equal to the square root of x squared plus y squared? So then r is equal to the square root of negative 5 squared plus negative 8 squared. So it's equal to the square root of 25 plus 64, which is the square root of 89. 89. Okay? So now that we know what x is, we know what y is, and we know what r is, we can give the values of the 5 remaining trigonometric functions. Let me give you a picture of what we have going on so far. So this is a picture of what we have going on. Remember, x is negative 5 and y is negative 8. So negative 5, negative 8. And this is your r value, which is the square root of 89. I can draw the perpendicular, if you like, to the x-axis. So then we have this triangle here. Okay? And this is your x value, this is your y value, and then this is your r value. Okay? So that's what we have in this problem. All right, we need to figure out sine of theta. Now, sine of theta is defined to be y over r. So to be negative 8 over the square root of 89, right? But when we rationalize, we multiply the numerator and the denominator by the square root of 89, and that will give us negative 8 root 89 over 89. This is the final answer for sine of theta, simplified, rationalized. Okay, let's keep going. Cosine of theta is x over r, so it'll be negative 5 over the square root of 89. Same thing, let's rationalize. Final answer for cosine of theta is negative 5 root 89 over 89. So this is our final answer for cosine of theta. Remember to always simplify your results. They gave us tangent of theta, so we don't need to find that. Cotangent of theta. You know what? Cotangent of theta is just a reciprocal of tangent of theta. In the very beginning, they told us tangent of theta is 8/5. That means cotangent of theta is 5/8, right? That was pretty simple there. Secant and cosecant are just the reciprocals of sine and cosine, okay? So then secant is a reciprocal of cosine will just be negative root 89 over 5, okay? That is secant. And then finally, cosecant. Cosecant of theta is the reciprocal of sine, so it'll just be negative root 89 over 8. Okay, there's our final answer there. All right, very good, guys. This is good stuff. All right, to wrap this lesson up, we're going to discuss our Pythagorean identities. Now, what we're about to discuss is very, very, very important. So let's start with the Pythagorean theorem, okay? Where x squared plus y squared is equal to r squared, where x is the length of one leg, y is the length of the other leg, and r is the length of the hypotenuse. What I want us to do first is divide each term by r squared. Divide each term by r squared. All right, divide by r squared, divide by r squared, divide by r squared. So this would lead us to x over r, quantity squared, right? That's true by the properties of exponents there. And then the next one would be y over r plus y over r, quantity squared, is equal to 1. X over r is defined to be cosine of theta squared, plus sine of theta, because that's what y over r is, quantity squared is equal to 1. Now, notationally, cosine of theta quantity squared is the same thing as saying cosine squared of theta. Plus sine of theta quantity squared is the same thing as saying sine squared of theta. Okay, now this, ladies and gentlemen, is your main Pythagorean identity. Okay, that's your main Pythagorean identity. Please jot it down. Please highlight it. All right, let's start all over. Let's start at the Pythagorean theorem again. And this time, I don't want you to divide by r squared. Let's divide by x squared. Divide each term of this identity by x squared. X squared, divide by x squared, divide by x squared. That would leave us with 1 plus, this is y over x, quantity squared, is equal to r over x, quantity squared. So then this is 1 plus tangent squared of theta is equal to secant squared of theta. This is another Pythagorean identity. Please add this one to your list, and we'll do one more. Okay, one more. Let's start with the Pythagorean identity again. The Pythagorean theorem again. X squared plus y squared is equal to r squared. This time around, let's divide by y squared. Divide each term by y squared. Y squared, y squared, y squared. That leads us to x over y, quantity squared, plus 1 is equal to r over y, quantity squared. Now, x over y is exactly how we define cotangent of theta. So this is cotangent squared of theta, plus 1 is equal to, now r over y is just cosecant of theta, but this is cosecant squared of theta. So this is the third Pythagorean theorem. So you have 3 Pythagorean theorems. It's very, very, very important that you understand how to write each one of them and how to write them correctly. Okay, let me summarize them maybe on the next page. Okay, these are your Pythagorean identities. It's very important that you write them down correctly and that you remember them really well. I do want to tell you that if you subtract sine squared of theta from both sides, you're going to get this alternative form. I'll write it down here. Cosine squared of theta is equal to 1 minus sine squared of theta. I got that by subtracting sine squared of theta from both sides. Similarly, if we subtract cosine squared of theta from both sides, we would get sine squared of theta is equal to 1 minus cosine squared of theta. These are alternative forms for this Pythagorean identity. Okay, very important. I want to talk about the quotient identities before we end this lesson. Notice the following. Notice what happens when I do sine theta divided by cosine of theta. Now, sine of theta is defined to be y over r, is it not? And then cosine of theta is defined to be x over r. So then this is really y over r divided by x over r, which is the same thing as saying y over r times r over x, correct? And then you would have your r's divide out. And notice that when you divide sine of theta by cosine of theta, all you're left with is y over x, which is tangent of theta. So that's a quotient identity. That tangent of theta is equal to sine of theta over cosine theta. Now, similarly, I can show you that, or you can do this on your own if you'd like. That would be even better. You and I can show that cosine of theta divided by sine of theta will be equal to cotangent of theta in a similar way. So let me write down your quotient identities formally and really neatly for you. All right, these are your quotient identities. Okay, cool. Make sure you have those handy. Notice of all of the identities that were creating and deriving in our class. We have the reciprocal identities, the Pythagorean identities, the quotient identities. All of these lists of identities are extremely important. Okay, let's do an example. Okay, find cosine of theta and tangent of theta, given that sine of theta is negative root 2 over 3 and cosine of theta is positive. Now remember from your Pythagorean identities, we had this alternative form that cosine squared of theta is equal to 1 minus sine squared of theta. That's listed as an alternative form of your Pythagorean identity. So what I'm going to do is plug in what they gave me. So then I have cosine squared of theta is equal to 1 minus, now sine of theta is negative root 2 over 3, and I need to square it because that's what the identity says to do. So then I have cosine squared of theta is equal to 1 minus 2 over 9. That's the same thing as saying cosine squared of theta is equal to 7/9. Let's take the square root of both sides. I'm going to come over here now. If I can show you, I'm coming over here to work. If I take this square root of both sides, I have cosine of theta is equal to plus or minus the square root of 7/9. Cosine of theta is equal to, now, plus or minus. Well, they already told me that cosine of theta is positive, so I can ditch the negative and just say this is a positive value, and it's positive root 7 over 3. Cool, so that's one answer. That's cosine of theta. I found it using a Pythagorean identity, this one here. Okay, now they want us to find tangent of theta as well. They want us to find tangent of theta. To find tangent of theta, I suggest we use a quotient identity. So let me move this up for us, but leave cosine of theta on the board. Here, look at this. So let me change colors here. All right, they want us to find tangent of theta, but we have this identity that tangent of theta is equal to sine of theta over cosine theta. And they gave us sine of theta. Sine of theta is negative root 2 over 3. And we just found cosine of theta to be root 7 over 3. So let's just divide or simplify this, and then we have our answer. So tangent of theta is equal to negative root 2 over 3 times 3 over root 7. Your 3's divide out, and you're left with negative root 2 over root 7, which we have to rationalize. And it'll become root 14 over 7. In order to rationalize, I need to multiply the numerator and denominator by root 7. So multiply the numerator by root 7, so it'll be root 2 times root 7, which is root 14, and then multiply the denominator by root 7, which just turns to 7. So then this is the answer for tangent of theta. Awesome. Let's look at one more example before we end this lesson. All right, find sine of theta and cosine of theta, given that cotangent of theta is negative 7 over 24, and theta is in quadrant 2. All right, everybody, because they gave me cotangent of theta, I want to use this identity. Cotangent squared of theta plus 1 is equal to cosecant squared of theta. Let me show you a little bit about, of my thought process. They gave me cotangent of theta. I want to use this identity because I can plug in what they gave me for cotangent of theta and solve for cosecant of theta. And once I have cosecant of theta, I can just reciprocate it and it'll give me sine of theta. So let's do that now. Cotangent of theta is negative 7 over 24. I have to square it according to the identity. This is 49 over 576 plus 1 is equal to cosecant squared of theta. This turns out to be 625 over 576 is equal to cosecant squared of theta. Be careful with your arithmetic. The number 1 is really 576 over 576. And when you add that to 49, you get 625 over 576. Let's take the square root of both sides. And when you take the square root of both sides, you get cosecant of theta is equal to plus or minus the square root of 625 over 576, which is plus or minus 25 over 24. Now, should we be taking the positive root or the negative root? Well, let me scroll back up here. Look at the instructions. It said that theta is in quadrant 2. And in quadrant 2, cosecant along with sine is positive. So we're going to go ahead and take the positive root because we're in quadrant 2. So cosecant of theta is equal to positive 25 over 24. Now, that's what the Pythagorean identity, this one here, led me to. Now, of course, they never asked us to find cosecant of theta, but they did ask us to find sine of theta. So now I can just reciprocate it. Sine of theta is a reciprocal of cosecant, so it must be 24 over 25. So it was the Pythagorean identity that led me there. All right, the last thing they want us to find is cosine of theta. So let's find cosine of theta. Remember the Pythagorean identity that you and I wrote down a little while ago, and it says cosine squared of theta is equal to 1 minus sine squared of theta. And we now know what sine of theta is. So then this is 1 minus 24 over 25. Don't forget, you have to square this according to the identity. So then we have cosine of theta, cosine squared of theta, is equal to 1 minus 576 over 625. Remember, the number 1 can be rewritten as 625 over 625, which would lead you to cosine squared of theta is equal to 49 over 625. When you take the square root of both sides, you get cosine of theta is equal to plus or minus the square root of 49, which is 7, over the square root of 625, which is 25. Now, don't forget, theta is in quadrant number 2. And in quadrant 2, cosine is negative. So I will say that cosine of theta is negative 7 over 25. You want to make sure that you are choosing the correct sign. So pay close attention as to which quadrant your angle lies. Okay? I do want to say that there is another way that you can find these function values, folks. You can actually sketch this angle theta that we're talking about in standard position. I didn't do that here. I used the identities because we are introducing the concept of an identity. And so I just wanted to kind of really teach that method. And I've already shown you how you can draw a sketch an angle theta in standard position. You can actually reference example, let's see, example number 5. Yes, example 5. I showed you how you can sketch an angle to get an idea of what you're looking at and then solve it that way. So there is another way you can get these function values, but what I showed you here is using an identity. All right, everybody, this is the end of this lesson. It was full of rich information, so make sure you take really good notes here, okay, for this lesson. All right, I'll catch you later.